In example 1, we need to write the system of linear inequalities that models each situation. Notice it doesn't say solve, it just says write the system. So in A, suppose you have a job mowing lawns that pays $12 an hour. You also have a job at a clothing store that pays $10 an hour. And then you need to earn at least $350 per week. And you must work a minimum of 10 hours per week at the clothing store. We'll write a system of inequalities that models how many hours per week you can work at each job and still meet the requirements. So let's define some variables. Let's let M equal the hours mowing lawns, and let's let C equal the hours at the clothing store. Those are the things that we don't know and that we're kind of concerned with here with this word problem. The next thing we're going to do is we're going to look at a few of the sentences. Here it says you need to earn at least 350. So that could be more than 350 or equal to 350 per week. We also know that mowing lawns pays $12 per hour. So the amount you're going to make from mowing lawns is 12 times the number of hours, which is M, you spend mowing the lawns. You need to add that to 10C. The store pays $10 per hour, so the total you make will be 10 times C. And you want that to be greater than or equal to 350. That's what this word at least means, or these two words at least mean. Also, you must work a minimum of 10 hours per week at the clothing store. So, C has to be greater than or equal to 10. If you work 10, you've got it. So that's why we're including an equal to symbol here. Notice this is the only thing that you know about each one of these. We don't know anything else about the lawn mowing job or anything else about the hours themselves. We just know that the total must be greater than or equal to 350 for how much you make, and then also C, representing the hours at the clothing store, has to be greater than or equal to 10. So actually this is the solution to this problem right here, not really the solution in terms of the word problem, but what we're asked to do is just write the system, and we've done it. We have a few more to tackle. Let's move on to B. In B, Phil is fencing in a rectangular area for a garden. He only has 150 feet of fence and wants the length of the garden to be at least 40 feet. We're going to write a system of inequalities that models the possible dimensions that his garden could have. Well, the possible dimensions, we're told it's a rectangle, so L is going to be the length. You can pick your own variables here, it really doesn't matter as long as you define them. And then we're going to let W equal the width. This is kind of an italicized L if you want, sort of a cursive L. He only has 150 feet of fence. Alright, well, if he's got to enclose the whole thing, the perimeter is 2L plus 2W. And he only has 150 foot, so the perimeter has to be less than or equal to 150. Also, he wants the length of the garden to be at least 40 feet. So L could be greater than or equal to 40 feet. That covers our statement right here. So really these are the only two that we need for this. Remember, the instructions were to write the system of inequalities that would help us, or that models each situation. In example C, Carla received a $100 gift certificate to Target and wants to buy shirts. The store sells t-shirts for $15 and dress shirts for $22. She wants to spend no more than the amount of the gift certificate. Carla also needs at least one dress shirt. And again, here we'll write a system of inequalities that models this situation. So as we think about this, we could let T equal the t-shirts, and that's kind of an italicized T there, and we'll let D equal the dress shirts. The store sells t-shirts for $15. So if you buy a certain number of t-shirts, you have to multiply that by 15, and that'll be the total cost. And dress shirts for $22, so we'll add 22 times D, which represents the cost of your dress shirts. And it says Carla received a $100 gift certificate and wants to buy shirts with that. So this total amount that she spends has to be less than or equal to 100. And I think for this here, oh, it does say she wants to spend no more than the amount of the gift certificate, so she doesn't want to use any more than 100. So that's our first one. And also here it says Carla also needs at least one dress shirt. So D has to be greater than or equal to 1. Could be more than 1, but she has to have at least 1. Here's our system of inequalities that models this situation. And the last one here, we've got part D. For a hiking trip, Joe is making a mix of X ounces of peanuts. So we've got our variable right here. I'm going to put a little squiggly line under that. And Y ounces of chocolate pieces. He wants the mix to have less than 70 grams of fat and weigh 8 ounces at the most. An ounce of peanuts has 14 grams of fat and an ounce of chocolate has 7. And we'll write that system of inequalities. Let's look at this grams of fat. If an ounce of peanuts has 14 grams of fat, we can figure out how many grams of fat you would have if you ate X ounces by multiplying that by 14. When we add that to 7Y, the 7 represents the grams of fat for each ounce of chocolate, and the Y represents the ounces of chocolate. He wants the mix to have less than 70 grams of fat. This is the total fat in the mix. So less than 70. Notice this is not equal to. If it's exactly 70, 70 isn't less than 70, so it's got to be a little lower than 70. He also wants it to weigh 8 ounces at the most. So if there's X ounces of peanuts, and we add that to Y ounces of chocolate, and we know that that has to be less than or equal to 8. In this case, it could be actually equal to 8. 8 ounces at the most, so 8 ounces is okay, but no more than 8. And so this adequately represents that situation.